Have you ever noticed just how easily our minds can, well, glitch? We jump to conclusions, we fall for fallacies, and we often build these really complex arguments on totally shaky foundations. But what if there was an actual mechanical blueprint to safeguard against those errors? Welcome to this explainer. Today, we're breaking down a truly revolutionary cognitive machine designed over 1,000 years ago, Avicenna's logical system, straight from the first section of his monumental work, the Book of Healing. We are going to examine the exact anatomy of how this legendary philosopher believed we could construct literally flawless thought.
To do this, we've got a pretty clear blueprint for today. We'll be looking at the ultimate thinking tool, time and truth, the square of opposition, the rules of syllogism, conjunctive and acceptive logic, and finally, the modal dodecagon. Let's get into it.
All right, Section 1, the ultimate thinking tool. Okay, so let's dive right into this. Avicenna defines logic as a regulative tool whose use prevents his mind from making errors. Think about that for a second. He's not treating logic like some dry, abstract philosophy here. No, it's a mechanical safeguard. It's literally like coding a software program so it absolutely cannot crash. Just like a ruler stops you from drawing a crooked line, logic is the specific tool that stops our minds from glitching when we're trying to figure out what's actually true.
But you might be wondering, what exactly is the raw material this tool is working with? Well, Avicenna argued that the specific subject matter of logic is what he called secondary intelligible meanings. Kind of a mouthful, right? But here's how to think about it. A first-level concept points to the real world, like the idea of an animal or a human being. But logic doesn't care about biology. It focuses entirely on second-level concepts. It looks at whether animal is acting as a subject or a predicate, or maybe universal in your sentence. By totally zeroing in on that formal structure, rather than the physical subject matter, logic guides us from the known right to the unknown. It guarantees a valid result, literally no matter what topic you're arguing about.
Moving on to Section 2, time and truth.
So, once you have that structure, you actually have to lock it down in reality. And Avicenna introduced this massive game-changing innovation to do exactly that. He added time to absolute propositions. In his work, Mantiq al-Mashirkayan, he breaks statements down into very specific temporal categories. For instance, a necessary proposition is true as long as the subject exists. But compare that to the determined category, which is only true at a specific determined time, like every moon eclipses. Or take the spread category. This is true at undetermined but regular intervals, like every human being breathes. It is incredibly practical. Avicenna realized that saying something like, every man is laughing, is technically false, unless, of course, you inject a temporal condition like, at sometimes. He's anchoring this highly abstract theory directly to how things actually exist in time.
Now, what's really interesting here is how Avicenna uses this temporal mapping to completely redefine how we contradict statements. If you make a general absolute statement, which basically means it's only true at some times, the only strict way to contradict it is with a perpetual statement. So if I say every subject is this predicate at some times, the true contradiction isn't just that some aren't. No. It has to be that some subjects are never that predicate. This level of extreme precision, it completely shuts down logical loopholes.
Which brings us to Section 3, the square of opposition.
Let's see how all this builds into the broader architecture of arguments. Traditionally, logicians used a literal, visual square to show how a statement like all humans are mortal relates to some humans are not mortal. Well, Avicenna completely bypassed those geometric drawings. You absolutely don't need to memorize the math here, but the concept itself is just brilliant. He defined these traditional relations, things like contradiction and contradictionary, using strict, almost algebraic truth condition formulas. Instead of drawing little shapes, he mapped out exactly when components must be true or false, depending on whether the matter at hand is possible, necessary, or impossible. It's a purely formal, essentially mathematical approach to language.
All right, Section 4, the rules of syllogism.
We've now arrived at the real climax of the blueprint. We are assembling the actual engine of reasoning, the categorical syllogism. And right out of the gate, Avicenna does something super bold. He streamlines the whole Aristotelian engine. Aristotle's followers had 4 recognized figures, basically patterns, of syllogisms. Well, Avicenna explicitly threw out the 4th figure entirely. Why? Simply because he deemed it an unnatural mental process. If the human mind doesn't naturally deduce that way, it just doesn't belong in his clean, efficient logic machine. Out it goes.
So the crucial point is that the rules governing the remaining figures are incredibly strict, and they have to be to keep the machine from breaking down. The general rule is that your conclusion must always follow the least, meaning the most restrictive premise when it comes to quantity and quality. For figures 1 and 2, the major premise absolutely must be universal, no exceptions. For figure 3, you can only ever deduce particular conclusions. And he didn't just casually state these rules, he rigorously proved them. He used logical conversion, he used proof by contradiction, reductio ad absurdum. And he even used this unique method called ekthesis, where you isolate a specific, designated part of a group just to prove a negative conclusion.
Let's move on to Section 5, Conjunctive and Exceptive Logic.
As we keep upgrading this machine, we see that Avicenna uniquely categorized the broader classes of syllogisms into two major buckets. First, we have the conjunctive, or ikterani. This is where your conclusion is deduced from two premises, but it doesn't explicitly appear in them. Then we have the exceptive, or istithnai. Here, the premises explicitly include either the conclusion or its direct contradiction. And what makes the exceptive category so brilliant is that Avicenna used it to seamlessly incorporate the propositional logic of the Stoics and Galen. We're talking about rules like modus ponens, where if a condition is met, the result automatically follows, and modus tollens, where denying the result denies the condition. He literally brought all these disparate logical traditions together into one unified, highly compatible system.
And finally, Section 6, the modal dodecagon. This is where we introduce the ultimate, most complex upgrade to a Vinis's system. This is what happens when you start modalizing propositions, adding those heavy-duty operators like necessarily or possibly. When you add those in, that simple four-sided square of opposition we talked about earlier, it completely shatters. To accurately map the incredibly complex relationships between these new statements, Avicenna had to construct a 12-vertex map. He upgraded the basic square to a massive, multidimensional modal dodecagon.
And this brilliantly illustrates the sheer depth of his thinking. Avicenna argued that necessity isn't just some linguistic label, it relates to actual being, how things physically and ontologically exist in the universe. Because of this, he typically placed the necessity operator internally, right at the end of a proposition, and doing that changes the rules of conversion entirely. Think about it. If you have the necessary proposition, every laughing thing is necessarily a man, you cannot logically convert that to some men are necessarily laughing. That's just false, right? Instead, it converts to some men are possibly laughing. The modality actually shifts to preserve the absolute truth of reality.
So, as we wrap up this explainer, it's clear Avicenna didn't just write a manual on how to win a debate. He engineered a pristine machine to align human thought with the absolute truth of the universe. By forcing us to account for time, for formal structure, and for necessity, he exposed the hidden mathematics of language itself, which really leaves us with something pretty wild to ponder. If logic is the tool that prevents the mind from glitching, how does the underlying structure of your own sentences shape the reality you perceive? Are you actually speaking in absolute truths, or are you just missing the temporal conditions? Definitely something to think about the next time you try to win an argument.